Hi, I'm Peter Manos, Director of Research at ARC Advisory Group. I'm in the energy group with utilities and smart grids being my specialty. And we have Jack Leahey of Beyond Limits with us. Hi, Jack.
Hi, Peter. Thank you.
Thank you for joining us.
Oh, my pleasure.
So I think our listeners will find it really interesting to learn about not just the digital transformation activities and value that Beyond Limits is bringing, but also your companies and your history when it comes to how it all evolved. So we like to say something's not rocket science, but there's some rocket science here this time.
There certainly is, Peter. Yeah, Beyond Limits is origins are Jet Propulsion Laboratory in Caltech. And so this is the AI technology that drove the Mars Rover program. So we might know a little bit about autonomous driving and AI. And so it's our job to take that technology and industrialize it. And we've done that, and we now produce several applications.
Fantastic, Jack. So we're not just talking about machine learning and the flood of data and applying that in different automation environments in different industries, but also a cognitive AI aspect. Could you explain to our listeners what that value proposition is and what you're seeing out there?
Certainly. The numeric AI, or machine learning, that most people know about, takes many months, years of history data, clean data, to train these models. And then you're never guaranteed, because of the dynamic nature, especially the process industries, if that model can stay trained. So what do you do when the dearth of data or noisy data as an upstream oil? Okay. That's where we extract human knowledge. And we take subject matter experts and we try to digitize their 30, 40 years of experience into best practices and into a cognitive AI reasoning technology, which will then be driven by data to show thresholds and alerts and alarms, but then goes through a reasoning that we extracted from the human being, human knowledge, to actually come out with what the action advisory is to the operator or to the engineer.
Fantastic. So upstream oil and gas and other parts of the oil and gas industry and other industries, these are asset owners with large fleets of assets. I guess there's the horizontal aspect of particular type of asset having variations facility to facility, or manufacturers, or the ages of them, and application environments. So is there like a hierarchy of these things that helps make an interface to transfer that knowledge to new users and that sort of thing?
Yeah, and we really look at the network of assets, Peter.
The network, okay.
So we're not really in the predictive maintenance or machine health business. So we're more into the system optimization business.
Okay.
So an example would be upstream oil. When you're looking to do drilling a new well in a brownfield reservoir, we will use AI and probably do it 10 times faster than simulation to tell you where to drill most optimally and then what the ROI is going to be. And that is very, very valuable to drillers. As you go to production, we have a well health solution that does sand management advisement. Okay. And so I know when sand comes up with the oil, it ruins artificial lift, it erodes chokes, it erodes the piping.
Impeller blades, all of that.
All of it.
Pitting.
Yeah. Yes, yeah. And so if you actually knew how hard you could run your flow and knew what the sanding risk was, you could change your operational strategy. And that's the advice that we give to the well operators.
So you have a complex assembly of equipment to simulate that. One of my visions, let me just back up for a second. So you probably know how in the semiconductor industry, they can take computer chips, burn them in at high temperature, accelerate the failures, and then before building a box and selling it, this complex assembly of chips, they can actually take the bathtub curves of all those components and mathematically say, here's the reliability of this very complex computer, right? And they can predict how many service personnel they're going to need to allocate. With these hard assets in utilities industry and oil and gas and CPG, all these industries, you don't have that luxury. They're much less predictable, these pieces of equipment with that kind of, the physics is different, right?
That is correct.
So is my hope, my suspicion is that what you're talking about, you've built things that could actually kind of do the same big component impact failure analysis, is what they call it in the semiconductor industry.
Yeah, interesting.
So here you're talking about something like that with industrial equipment where you need a lot more data, a lot better
Yeah.
leveraged data, right?
So so we're not looking at the failure rates of individual assets. We're looking at the whole connected process
Yeah.
and how to advise the people who have to run it day after day on how to get the optimal economic impact out of that.
Okay.
So let me give you an example on power, because I know you're a power expert, Peter. So cogeneration plants, mainly complex ones with 3 trains. They are supplying steam to a refinery and bidding power into the grid.
District heating or industrial steam.
Correct.
Yes. Okay.
Right? So there's many, many ways to operate these systems. Set points, probably, orders of magnitude, of set points. And so we use a simulator, a thermodynamic simulator. We run it 50 million times and train a proxy.
50 million.
50 million. And we train a proxy AI model. And then that proxy AI model can run in seconds using an optimizer.
Wow.
So if you know what your steam commitment is and you can't miss that contract, but you know the pricing of electricity.
You have flexibility on the wholesale electricity market, so that's your,
correct. And
secondary variable, right?
this system would come back and tell you, here is all the set points in all 3 trains to save you fuel, usually 2 to 5% fuel savings, and meet your economic commitments, and take advantage of a market opportunity on a bid.
That is awesome, Jack. So the steam send out is optimized. The heat rate in terms of electricity production, suboptimal, but as optimal, it's totally optimized for the full goals that you're trying to meet.
That's correct. Yeah, if you
Wow.
take that 50 million simulation and you look at the process space, a 3-dimensional space, most operators operate in a very small space because they operate where they know in the middle,
Right.
and they don't experiment with all these other things. So there's too many.
Yeah.
And so when you come out with novel set points with people, that's how you end up saving fuel and being able to make more steam and more electricity and make more money bidding into markets on an opportunistic basis.
So there are probably a lot of other examples where you've come to these discoveries in terms of the end user going, well, that seems counter. Oh, that works. Wow. I mean, is it like that kind of like light bulbs go off? And
All the time.
Okay.
So we have another application, it's Refinery Advisor. So it has a full refinery model.
Okay.
And it's actually advising operators on turning valves certain directions to meet economic objectives. So everybody knows that you plan your economics. You buy a crude, you have demand, you plan, you think this is the best crude to buy, and we're going to make this much gasoline, diesel fuel, jet fuel.
Like the whole mix. Yep.
World's dynamic. Everything changes. Normally, there's adjustments that need to be made to that plan,
Right.
obviously. So we also optimize those objectives with real-time pricing. We all know that the really fast swings in market prices today. Every day, gas is more expensive, right?
Yep.
But your plan that you did, 2 weeks ago didn't count for this much increase. We'll readjust those. And as we readjust those targets, they go to operators. But then we only don't give the target to the operator. We tell them how to achieve it when they're running in real time.
That's fantastic. And I can imagine the supply chain side of that has optimization too, if there's uncertainties about or changes in what's coming in for the feedstocks for those processes.
Correct. We help with feedstock selection, both in month and out month. And a lot of times people buy a feedstock, but something else comes in.
Interesting.
And many times if you're out of tank storage areas, you might use a half a tank that had another feedstock in it, and now it's a mixture. So there's a lot of variables that are juggled in the process industries every day.
Excellent. And I think with the energy transition, industries are going to have cross-industry workflows that are going to change in new optimal ways where they might be co-optimizing, pulp and paper process that's fed by a forestry or, agricultural process that's giving feedstock to a biofuel facility, right?
Correct.
So
Correct. We're involved in a biodiesel project. Right now, we're also involved in a green hydrogen project, which would be feeding an agricultural fertilizer nitrogen plant.
Fantastic.
Ammonia plant, rather.
Well, thanks for that contribution to the energy transition, Jack. Any last thoughts you'd like to leave with our listeners?
I think it's a very big and complex field, and there's a lot of players. And I think we all have a place to fit, and we all have a specialty. And so, beyond limit specialty is the human knowledge combined with the data approach. If you're short on data or noisy data, we can pick up on the human knowledge, or we can do both. And it's called cognitive AI, numeric AI, but Gartner has termed it hybrid AI.
Hybrid AI.
Yep.
Excellent.
So we're happy to work with anybody that's listening.
Thanks. Thank you so much. Well, we've been listening with Jack Leahey of Beyond Limits, and this is ARC Advisory Group thanking you for joining us.
Thank you, Peter.
Thank you, Jack.